Lesson 5.4, Solving Compound Inequalities. Compound inequality is when two inequalities are considered together. When two inequalities are considered together in one statement. There are two kinds of compound inequalities that we will look at. The first is the intersection inequality, and the key word that you'll look for to identify it is the word and. With an intersection type of inequality, you will graph only the points that both inequalities have in common. The and inequalities, or the intersection inequalities, will look one of two ways. Okay, you may see a statement that looks like this, where x is in between, and you have two inequalities written as one statement. You read it this way: 3 is less than or equal to x, which is less than 7. Another way that you'll see a compound and inequality is written this way. It's the same inequality but written in a different way. X is greater than or equal to 3 and x is less than 7. Okay, I want to take a moment to show you how these intersection compound inequalities are graphed. On this graph, I'm going to graph the first inequality, which is x is greater than or equal to 3. Okay, let me graph that. Greater than or equal to 3 means I have a closed circle on 3, and I would be going all the way to the arrow, everything to the right. If I were to graph x is everything less than 7, then what I would do is I would have an open circle on the 7, and I would graph everything to the left, including the arrow. Okay. Now, because this is an intersection, an and type of compound inequality, x has to meet both criteria. X has to be both greater than or equal to 3, and it must also be less than 7. So what we will graph when we graph our compound inequality, which I'm going to do for you now, I'm going to graph the compound inequality. 3 is less than or equal to x, which is less than 7. We only graph those points that they have in common. So closed circle there, open circle there, and only those points in the middle are the ones that are shaded in. Okay, so there, what you have shaded is everything that is greater than or equal to 3 and also meets the criteria of x is less than 7. Okay, so this is the first kind of compound inequality. Okay, remember a key word is and. Okay, now let's look at the second type of compound inequality, and this is the union. And it's also, the key word is or. For this kind of compound inequality, you're going to graph all points for each inequality together on one graph. Everything goes. So everything for one inequality, and you're also going to shade everything for the other inequality, and you're going to shade them together on one graph. Okay, when you see an or inequality, it'll always have the word or. There's no guessing. Okay, so here's an inequality. X is greater than or equal to 3, or x is greater than 5. And what I want to do, just to demonstrate how this works, is I'm going to graph each one separately, and then I'll graph the compound inequality last. If I had to graph x is greater than or equal to 3, I would have closed circle over the 3, and everything to the right is shaded. If I were to graph x is greater than 5, then I would have an open circle on 5, and I would shade everything to the right. Okay, because it's a union, I'm uniting both of these graphs together. What I want to do is I want to include all of the solutions from one inequality as well as all of the solutions from the other inequality. Let me show you how I would graph this inequality that says x is greater than or equal to 3 or x is greater than 5. Well, I would have a closed circle on 3, and everything to the right would be shaded. Everything. And that includes every solution from both inequalities. Okay? So again, just to review, the AND is an intersection. You're only going to graph the common points. The OR is a union. You're going to unite all the points and graph them together. Okay? All right, let's continue. Let's just look at some and start solving them. Copy down number 1. Pause the video for a moment. Okay. Keyword is here. This is an AND situation. That means we have an intersection. So let's solve each of these. Okay. So n minus 2 is less than or equal to negative 5. We'll subtract 2 from both sides. N is less than or equal to negative 7. Okay. Then I have here n plus 6 is greater than or equal to negative 6. So we'll subtract 6 from both sides. And I have n is greater than or equal to negative 12. And we'll recall this is an AND situation. Okay, so the way that I like to do this is I would like to first just lay down some numbers. I have negative 13, negative 12. Those are important numbers. Negative 11, 10, 9, 8, negative 7, negative 6. Okay, so we have the basic numbers that we're dealing with here. N is everything greater than or equal to negative 12. So I know that on negative 12, I'm going to have a closed circle. Okay? Closed circle on negative 12. And then n is everything smaller than or equal to negative 7. So I need to have a closed circle on 7. Okay, so notice with me that n is less than or equal to negative 7 would be going to the left. N is greater than or equal to negative 12 would be going to the right. So everything in between these two, and these two will have closed circles, should be highlighted. And then from the graph is where I write my solution. Solution set, all values for n, where? And I'll write it right from this solution set. Negative 12 is less than or equal to n, which is what's shaded, which is less than or equal to negative 7. Okay. All right, number 2. On number 2, notice that this is an OR. An OR is a union. It's a union graph. So what I need to do is I need to just graph both of them together on one graph, and every point that's included on each of them will all be graphed on one number line. So let's start here. T plus 14 is greater than or equal to 15. Let's subtract 14 on both sides. And I have T is greater than or equal to 1. Or T minus 9 is less than negative 10. Let's add 9 to both sides. And I have T is less than Negative 10 minus 9 is negative 19. Okay, so t is everything greater than or equal to positive 1, or t is everything less than negative 19. All right, with my or, this would be my solution. And of course, I would have to write it in set notation. So I'd just say all values for t where, and I'd put that in brackets. Okay, so that is my solution right there. So let's lay down the numbers that I need. I need positive 1 there, 0 is there. And here's negative 19. Okay, so t is greater than or equal to 1. So on the 1, I need a closed circle. And I'm going to highlight everything greater than 1 going to the right. And then t is everything less than negative 19. So open circle on negative 19. Hey, I just realized the mistake that I made, and I know it's because it's kind of late. But let me fix this. I had to add 9, so there we go. T is less than or equal to less than negative 1. Okay, that's better. All right, so let's do this. So here's 0. Here's negative 1. Here's positive 1. I'll put in 2 and a negative 2. And I'm sorry about that. But t is greater than or equal to positive 1. So again, I'll have greater than or equal to positive 1. All of that will be shaded. And then less than or equal to negative 1 means open circle and highlight to the left. So here's a union of both those graphs with all the solutions on one number line. Okay? All right, number 3, I want you to try on your own. Please notice, or actually no, I'm going to do this one with you because this is an and. I want you to recognize that when you don't have the word or and it's combined like this, it is definitely an and, which is, an intersection. When they are written together like that, in order to solve them, we will separate them. So let's write it separately. Negative 3 is less than or equal to 7c plus 4, and 7c plus 4 is less than 18. And we're going to solve for c. Okay, so subtract 4 from both sides. Negative 7 is less than or equal to 7c. Let's divide by 7 on both sides. And we know that negative 1 is less than or equal to c. Right here we have to subtract 4 on both sides. We have 7c is less than 14. And divide by 7 on both sides. And we have c is less than 2. So we can reunite now both of these statements and come up with one compound inequality that looks like this. Negative 1 is less than or equal to c, which is less than 2. And so we would write it all values for c where negative 1 less than or equal to c is less than 2. And from there, it's very easy to graph my inequality. Okay? So I have 0, 1, and 2, negative 1, and negative 2. Negative 1 is less than or equal to c. That means that c is everything greater than negative 1. So we're going to have, hang on a second. Okay, we're going to have a closed circle here. And that would be shading to the right, correct? And then C is less than 2, so I'm going to have an open circle there, and we're going to shade everything to the left. But of course, we're only going to shade the points that they would have in common, which would be the points in the middle. Okay? All right. Number 4 is an OR situation. Pause the video and do this one on your own. Okay. On number 4, we find that M is everything smaller than or equal to 6 or everything greater than or equal to 6. So you can safely say that M is all numbers. And every number on your number line is highlighted. Number 4. Okay. Let's do some graphing and practice problems. For graphing, number 1, number 3, and number 5, just graphing these are all and intersection. Type compound inequalities. Okay? And then solve 7 and 10. And on this page, these are all or unions, where you graph everything. I want you to graph 1, 3, and 5, and then solve 7 and 10. Okay? We will work on this tomorrow, so be ready for any questions that you might have. We can go over the examples together. If you have anything that you need to ask me, make sure that you write it down so you don't forget. All right, God bless you. Have a great night.